This is the makeup investigation for the lab that we missed the past Thursday. The guiding question for it is, what is the optimum mole ratio for a reaction? So what I'll be doing here is explaining how the reactions worked and the purpose and the scope of the investigation. After that, there will be an associated Excel sheet that will provide you with sample data, and then based on that, you can write the investigation report. The lab is all about reactions. It's all about taking starting materials or reactants and turning them into products. So when we are, let's pretend we're making something. Let's say we're making cake with the available ingredients in our kitchen, and maybe we're selling the cakes. So there's certain criteria that we want that will, for us, mean whether or not something's optimal. What we want is we want to make as much cake as possible. So we want to maximize the amount of product that we're making. In addition to that, when you cook something, sometimes ingredients can be expensive. You don't want to go out and buy an ingredient that's expensive and only use up a little bit of it. So the other criteria for how optimum something is going to be is having minimal amount of leftovers, minimal amount of starting ingredients. So now let's talk about the recipe. What we mean by a recipe is the chemical equation. So in this investigation, we looked at two different chemical reactions. The first one involves sodium bicarbonate, that's this right here, that is otherwise known as baking soda, reacting with acetic acid, that's vinegar acid. The other reaction involves calcium carbonate, CaCO3, that's otherwise known as chalk, reacting with this right here. This is the same formula as the one above. This is also acetic acid. So the products that the first one makes are three of them. We make carbon dioxide, we make this, and then we make water. The other one makes pretty similar products. It also makes carbon dioxide. It has this product here, and then it also makes water. So here's how we would approach this. We would take a flask and put the reactants in there, put a stopper on it, connect that to a rubber tube, and then put that in a graduated cylinder filled with water that's upside down in the sink. So what would happen is when this carbon dioxide gets produced, when these two react with each other, we make carbon dioxide and it goes along the tube and it fills the graduated cylinder. So we can measure the volume of the carbon dioxide that we would have made. The more CO2 is desirable. So now what we could do is, if we're trying to figure out what is optimal in terms of mixing these two, we could take this mixture and vary how much of each one is in there. So for the first one, we could put in 1 part of sodium bicarbonate to 10 parts of the acetic acid. In the next one, we could change that a little bit and do 1 to 2. We could do 1 to 1. We could do 4 to 1. So now there's more of the sodium bicarbonate present than the acetic acid. And then finally, we could do 5 to 1. So these are 5 different mixtures that we would have looked at. So we can express these two numbers are in a ratio with each other. And we can take the amount of sodium bicarbonate and divide it by the amount of acetic acid. 1 over 10 in this case gives us 0.1. But what it really means is that for every 1 sodium bicarbonate, we have 10 acetic acids present in the flask. The second one is going to be 1 over 2, that's 0.5, 1 over 1, 4 over 1, and then 5 over 1. So this ratio of how many is applied to moles. Moles measures how many. So these numbers right here, these 5 numbers, represent the mole ratio. And we're trying to see which one of these is optimal for the sodium bicarbonate and for the calcium carbonate reactions. When reactions happen, reactants will run out. Eventually a reaction goes and goes and goes until something runs out and we're left with the other reactant. So that's what could happen for the first one. Maybe we have some acetic acid left over. Again, maybe there's acetic acid left over, but there's a different amount. Theoretically, both of them could run out. We could have 0 left over. And then on this side, we could have some sodium bicarbonate that's left over. Well, what we're shooting for here is, remember we talked about one item that makes something optimal is the amount of leftovers, and we want to minimize that. So what we're looking for is the amount of leftover reactant to be minimal. Less is optimal in this case. The other thing we have to look at to determine whether which mixture is optimal is the amount of CO2 that it makes. In this case, we're defining optimal as more. The more product that we get, the more optimal that it is. So that's how we're going to make the determination as to which of these 5 is the optimal mole ratio. So now what we're going to look at is the experimental data. So the spreadsheet that I'm going to bring up is going to match the one that you'll get a link for. So when you open up this spreadsheet, you're going to need to download your own copy of it. There are several tabs down here. The first one shows the chemical equations, aka the recipes that we're working with. And in order to move forward, what we have to do is balance these chemical equations. Now the first one is actually balanced the way that it is, which is to say that each coefficient is 1. So on your spreadsheet, you can just go through and put in a 1 on each of these. For the second reaction here, there is a slightly different set of coefficients. This one's 1. This one actually ends up being 2, and then a 1 for the rest of them. So this is the recipe. What it's saying is that 1 sodium bicarbonate combines with 1 acetic acid to make 1 carbon dioxide and 1 of the other products. This one says that 1 calcium carbonate combines with 2 acetic acids, so that's different than the first one, to make 1 CO2. On the next tab right here, what this will show you is these are amounts that we would have started with. These are amounts that we would have measured out into our flasks in the lab. And we're making the assumption that the reaction proceeds until one of the reactants, one of these, runs out, i.e. it reaches 0. So for this reaction here, you can see that you're starting with 0.002 moles of that, you're starting with 0.02 moles of acetic acid, and then after the reaction goes, we have no more sodium bicarbonate left, and then we have some amount, we have 0.018 moles of the acetic acid here. This process is repeated for the calcium carbonate reaction here. As for the amount of carbon dioxide, you're going to need to be provided with some values. So on this third tab over, what we've got are the 5 reactions. We have the mole ratio that we looked at a minute ago. And then these numbers right here are experimental values. These were values measured by one of the sections of, one of the sections of lab. So this is measured in terms of volume of carbon dioxide, and that's in milliliters. So these are just provided values. This is how much we would have gotten. And then if we put everything together, we have these 2 sets of graphs here. This is for the sodium bicarbonate reaction. What this first graph is showing is how much leftover we've got, and that was one of the criteria we're looking at for whether or not something's optimal. The second graph here shows the mole ratio, once again, so the same x-axis, but what we have here is the volume of the carbon dioxide that got produced. This is repeated for the calcium carbonate reaction. This is the amount of leftover reactant, and then this is the amount of carbon dioxide that got produced. So the goal here, the answer to this guiding question, what is the optimal mole ratio of for a reaction? It's going to need an answer for this reaction and for this reaction right here. So that should do it. You should have enough information to start working on the investigation report this time. On Blackboard, you'll see that under course content, under this tab right here, there is investigation report number 3. And if you click on that, you'll see that the due date has been pushed forward an additional week. So this is going to be due next Thursday, October 31st at noon. And what you can do is you download this link right here, Investigation Report 3. You type up your report, and then you are going to attach it right here, just like the other ones. And that's how we will do it. If you have any questions, please let me know. Thank you.